Good evening, Prashant.
So, good evening, everyone, and welcome to the Web Symposium, jointly organized by Sika Asia and me, Polymer Pipes. So, I'll quickly share today's agenda, and I request all the participants to please stay muted. Thank you so much. Thank you. So, I'll quickly, first of all, share the agenda for the day. So, let's get started. So today's agenda is today's topic for the web symposium is polymer concrete pipes, its advantages and applications. This web symposium, as I shared earlier, is jointly organized by Sika Asia and me, Polymer Concrete Pipes. The speaker for the day is beloved Mr. Walid Bahsow. He is the CEO of me, Polymer Concrete Pipes. The web symposium, I'll quickly share about Sika Asia in 10 to 11 minutes. And then I'll give the speaker introduction followed by the symposium, which will go for approximately 1 hour, 10 minutes. And then we'll have the Q&A at the end of the session. So I request everyone to enjoy the web symposium and be ready with your questions for the Q&A session. So let's know about our speaker for the day. So Mr. Walid, previously he was working as a general manager with a proven success record in company restructuring, development and improvement. He has an experience of more than 15 years in various fields of the composite industries, and he has extensive expertise in production processes, procurement, quality control, installation and management of GRE, GRV, GRP and FRP pipes and fittings, polymer concrete jacking pipes and manholes, unsaturated polyester resins and vinyl ester resins. So he has a really extreme experience in polymer concrete pipes, and we are very much proud enough that he agreed upon doing this web symposium. So thank you, Mr. Wallace, for joining us. Thanks a lot. Yes, thank you so much for joining. So I'll quickly share about Sika Asia. So Composites Excellence Center of Asia is the center of excellence which was set up by adapt and accomplished professionals from composite industries, academics and research organizations. Sika is supported with ceramic technologists, polymer technologists, material scientists, mechanical engineers, chemical engineers and geologists to cover the complete spectrum of composites processing and control. Sika has been launched to provide support to composite industries in their growth journey through technical support, technical training, project consultancy, arranging technical and financial collaboration with composite companies from developed quarters from Europe and USA. And the special focus of Sika Asia is on the future generation to support and guide them for securing employment in composites field through support in education, training, internship, and finally selecting the right career, including higher education, guidance in foreign universities. Just a second. Yeah, I'm really sorry for the interruption. So that's about Sika Asia. I'll quickly share about Dr. Singh, the man behind Sika Asia. So he has an extensive experience of 35 plus years and into operation management, quality system management, and Lean Six Sigma implementation in composites manufacturing and allied industries. He has imparted training for more than 4,500 hours in-house to vendors and customers. He has extensively traveled across the globe, including many major countries like USA, France, Spain, Germany, Holland, and China. To share his knowledge, Dr. Singh is having BTech degree from IIC Kolkata. He has done his MTech in glass and ceramics, and he holds a doctorate degree. And he has done his PhD from Atal Bihari Vajpayee Triple ITM Gwalior. As I shared earlier, he's having 35 years of industrial experience working with Samsung Tech, Vuitton System, Dofner, and Schock German Technology. So he is presently associated with Sika as Director of Business Transformation and he's driving the composites movement in India with his fellow composite fraternity with the aim of something that is booming since past 1 year in the whole Sika, in the whole composite fraternity. And the moment that he says is he wants to make India the hub of composites manufacturing by the year 2030 onwards. So that's a great movement that he has initiated, and we are very much happy and proud that people have been associated towards it, and we are really working strong enough, hard enough, and we surely achieve this goal together. So next up, I'll share the areas of our services. The Sika services has been bifurcated into three verticals based on materials, processes, and markets in composite industries. So if we talk about materials, Sika helps industries who deals with aramides, carbon fiber, core, epoxy, fabrics, preform, polyesters, prepregs, and thermoplastics. If we talk about processes, we help additive manufacturing processes, compression molding, curing, infusion, pultrusion, RTM, and spray ups. And if we talk about markets, we cater umbrella of composite industries, which includes aerospace, automotive, construction, defense, marine, mass transit, sports and recreation, and wind and energy. So if I talk about the focus areas of Sika Asia, so Sika Asia acts as a catalyst in setting up composite clusters. The major thrust on renewable energy and sustainable transport like aerospace and automobile. Sika plans to encourage material development, manufacturing methodology, and design methods to get edge. Sika also supports new product development for efficient and cost-effective manufacturing. And the most important is that Sika believes to transform the existing composite businesses through lean leadership transformation. Sika also provides vital support in the skill set of composite professionals. We have pointed focus on research of composites of tomorrow, aligning industries, academics, R&D centers, and universities. Sika tries to bridge the composite industry professionals to R&D centers and universities from rest of the world. We continuously organize online trainings, seminars, and workshops like we're doing right now for the benefit of professionals and academics in the composite industry. And I repeat the statement, the movement that Sika has initiated with is to make India the pioneer hub of composites manufacturing on the earth by 2030. And we believe to remain in the forefront of composites development and support. This is the Sika support team headed by Dr. R.K. Singh, respected Mr. N.G. Sharma, Sir Chandran Kolon, Dr. Anshuman, Frank Weisty, and Dr. Ganesh Soni. If I quickly talk about the memberships at Sika Asia, so we have three memberships: individual annual membership, which is absolutely free. So I'll request you, if you're not a Sika member, visit sikaasia.com/memberships and get your membership. Honorary life membership, it's again a free membership, but it is being nominated by the Sika Asia core team members and the management team. So it's again a free membership, but yeah, Sika Asia nominates those members. The third and the important one is the corporate membership, which has a cost because it has many benefits. The cost of an annual corporate membership is rupees 11,000 or $160 per annum. And there are many benefits associated with corporate membership, which you can visit on sikaasia.com/memberships to see. And we're very proud enough to share this that currently Sika has more than 5,000 plus members associated who are part of this big movement that has been initiated. I'm very proud to share this again and again. So it's quite an achievement for Sika. So I'll quickly talk about other services that Sika provides. So Sika provides Manpower Data Bank, which is a free service to fraternity. It again helps both the professionals who want to be part of composite industry and the companies who look forward to hire professionals. So it's a completely free service to this fraternity. We have Sika Asia Communique, which is a monthly newsletter. We are starting it again. And we are very happy and proud enough that new things are coming up in the newsletter. And soon you'll get the information and notifications on LinkedIn and our website. We are introducing few directories on our website. All the directories are online, and it will include the membership directory, the impaneled consultants that we have, and I can see few of them have joined today, so I'm thankful to them. And also tool designers who are associated with Sika. So all these things will be soon available on sikaasia.com. So I'll quickly share what is happening in the month of August lately. So we are starting NDT for Advanced Composites, which will be a 50 hours course, which is starting from Monday, 23rd August. So today is the last day to register. So it's an evening course, which will be from 7 to 9, and the cost is rupees 12,500 per participant. If you have couple of participants along with you, there is a discount for which you need to contact us. You can register on cekasia.com/events, and our faculty is Sir Mr. Chandran Kolon. He's having more than 40 plus years of experience in NDT testing of advanced composites. He has worked with pioneer advanced composite industries like Hindustan Aeronautics Limited and TAML. He has done his Master of Engineering from Osmania University, Hyderabad. He has an ASNT NDT Level 3 ultrasonic testing, and he's also NES 410 Level 3 ultrasonic testing composite. So like, I don't see anyone else who would be the best faculty to teach NDT. So I request all the participants right now, if you go visit cekasia.com/events and look for the description to know more about the course. Next up, we are starting FRP Manufacture Remanufacture course in August 2021. This is for ITI 10, 12 pass students, like operators, as you say. So this course is starting from 5th to 9th September. The course fee is really minimal because we want to support the moment. It's only rupees 4,000 per participant. The faculty is Dr. R.K. Singh himself, who will be associated with Dr. N. Junare in the training sessions. So you can register on cekasia.com/events. Every month, I am very much happy that every month Sika is continuously doing this Lean Six Sigma Green Belt training and certification, which is which is very much important for an industry to run smoothly. And we have great number of participants every month. So even this month, this is like a 4 days weekend course, which will be happening from 13 to 18 September, evening 7 to 9:30 p.m. So this was something that we have shifted because of the number of participants, and they were asking it to keep in evening instead of having a full day course. They wanted to have it as an evening course, so we have quietly modified the whole course to accommodate in the evening sessions. So the course fees is rupees 6,500 per participant, and the faculty is Mr. P Singh. He himself is Six Sigma Black Belt certified, ASQ BEME, having more than 22 years of experience in manufacturing and service industries. Again, you can register on cekasia.com/events. So these are our touch points, or our clients, you can say, the success partners who have helped us in the moment of making India the hub of composites by the year 2030. We're very proud enough to be associated with such big companies, and thanks to all of them that they trusted Sika Asia for our taking our services or being our touch point. So that's it. Thank you so much for patiently hearing me. I'll now hand it over to Mr. Walid to take ahead the whole session. Thank you so much.
Thank you. Thank you very much. Good evening, everyone. You can please, yeah, okay. Share the screen. Okay. So I will go through the agenda first to give an idea of what will be covered today throughout this symposium. So first I'll go over what is polymer concrete. I'll explain what it is composed of, and then I'll discuss on the standards and main applications. We'll go over from there I will concentrate on the pipes. We'll go on the different pipe installation methods, followed by comparison between the open trench and the trenchless installations. After that, I'll show a video for those who are not aware of the microtunneling process, followed by the pipe selection criteria, an important point or important list of criteria which is required and important to select the right type of pipes for any project. Then we'll go on the types of pipes available in the market, followed by our pipes, the MI pipes. What are their advantages, the joint details, the quality control, and then I'll display some pipe comparisons, basically the comparison of the flow, the internal and external diameters, the weights and jacking strength for different types of pipes, and show some of the common problems in some of the pipes available in the market. At the end, we will go through the Q&A session. So please jot down any questions you may have, so we can you can ask them later on, and we'll be happy to answer them. So first of all, what is polymer concrete? It is a composite made of unsaturated polyester resins and aggregates. There is no cement and no water is added to the mix. Other names for it is polyester resin concrete or filled reactive resin molding material. This simply depends on the type of standard the person is following. So again, the contents, basically you have the aggregates, a mixture of the aggregates, stones and sand, mixed together with the unsaturated polyester resins. This is what the mixture looks like, just as it comes off the machine. Normally, the ideal way is to use computer-controlled machines to ensure that the standard, the batch mix is consistent and the quality is constant from mix to mix. After it is cured, it looks like this. The curing process, of course, is much different when compared to concrete or clay pipes. There is no requirement for any type of post-curing, I mean, long-term post-curing or heating. It takes about 1.5 hours to 2 hours max for the polymer concrete to be cured and ready for service. Of course, the maximum strength, we recommend that to wait for about 3 days to obtain the maximum strength. But of course, from after 1.5 hours, 2 hours, the pipes can already be used, or whatever the product is. So what are the applicable standards? You have initially the first standard which came to being was the DIN 54815. And this was then replaced by the DIN EN 14636-1. After the first DIN, there was the ASTM D6783, which is the standard specification for polymer concrete pipe. And the other common one is the BSEN 14636-1. The main applications, you have for polymer concrete, the main applications are for microtunneling jacking pipes, and it is also used for open cut pipes and polymer concrete manholes and drains. So these are some of the pictures showing the pipes, the drains, and the manholes. It depends on which part of the world. Some find the manholes like in the Central Asia, Far East Asia, Southeast Asia. It's considered they're considered pretty expensive when comparing with the concrete chambers. But in other places like Kuwait, Oman, Qatar, they are considered the ideal solution for the polymer concrete. I mean, to have polymer concrete manholes in the sewage system. So is it a new product? A lot of people are not aware of polymer concrete. It's quite a new term for them. So the question would come, is it a new product? The answer for that is no. The R&D for polymer concrete began more than 70 years ago. Previously, it was concentrated only in Germany, Soviet Union, USA, and Japan. It has been the preferred material for jacking pipes and open cut pipes in many countries and was installed worldwide. To name a few countries, we have Germany, Kuwait, Singapore, Australia, US, Qatar, Iran, Oman, Saudi Arabia, and Poland. Now, I've personally seen the increase in demand and the shift from the previously used pipe materials to polymer concrete in countries like Kuwait, Iran, and Singapore. Whereby previously the common material was either concrete pipes or clay pipes. However, as soon as the polymer concrete pipes were introduced, the authorities quickly realized the benefits of these pipes, the advantages over the older types, and the new standards, the new tenders were all specified on the polymer concrete pipes. So these are the different, some of the installations of polymer concrete pipes around the world, of course, different manufacturers. So what are the pipe installation methods available. We have the open cut, the open trench method, which is a traditional, the old way of digging the road and installing the pipes. And then you have the trenchless or the microtoweling and pipe jacking method. So this is a picture just to show the problems which one would face with the traditional open cut installation, where you have to dig the entire length of the pipes which will be installed. You have to dig the entire road, and you'll have a lot of disturbance to the traffic, a lot of traffic jams, road diversions, and I will get to these comparisons shortly. So this is a very common and painful sight. We see the diversions which will need to be taken, the roads which have to be blocked, other safety issues for anybody passing by. You can see this picture shows everything clearly. So safety issues for the passers, the disturbance to the neighbors, the traffic jams, all are common sights, and especially in old crowded cities. The heavily populated cities, this is the worst type of installation which can be used for installing the sewer pipes for the new networks or even for upgrading the older networks. So what is the alternative? It is the trenchless technology, and that you'll have basically the road will not be affected. There will be minimal disturbance to the traffic. You'll only need to have the lowering shaft and the reception shaft. That is the only place which will be dug, and the pipes will be installed underneath. So we will come shortly to the description, the comparison. So there are many different aspects. The first one is the soil disruption. In the open trench, as I mentioned, you'll need to remove the entire soil throughout the length of the pipes and to the required depth. Whereas in the trenchless, as I mentioned, it's only for the lowering and the reception shafts. But in between the pipe, throughout the pipe length, it's only the area of the pipe which will be removed. All the soil which is above the surface, above the pipe, will remain intact, and all the facilities, the utility cables, everything which is above the line will not be touched. So the second thing is the backfilling. For the open trench, you'll require to remove the entire soil throughout the length of the pipes, and then you'll have to import special soil for the bedding, lay the pipes, and then put additional bedding material, followed by either the native soil or a different type of soil to fill up the balance of the depth which is done. And then for the trenchless, throughout the pipeline, this will not be required. The only removal of the soil, it will be through the area of the pipes which are installed, and the lowering and reception shafts. For the surface preparation, rework asphalt, again, it is completely required throughout the line for the open trench, but for the trenchless, it's very minimal. The line may be designed in places such that the lowering and reception shafts can be put in non-critical areas away from, let's say, road crossings or heavily trafficked areas. So the presence of these shafts will not impact the traffic and the neighbors. So there'll be minimal disturbance. The risks involved, you have higher risk, of course, for damaging in terms of the open trench. You have higher risk in terms of damaging the existing utilities, whether it is power cables, telephone lines, previous sewage lines. For older cities, the drawings and the exact location of these lines may not be available, and that will impact greatly. It will be very risky during the installation process. For the trenchless, again, this is reduced almost to zero. Another impact is the environment. Due to the need that for removing the entire soil and bringing it back, all of that requires equipment for the digging, for the transfer of the soil, and all of these emit carbon dioxide. And this is greatly reduced with the trenchless process. For the traffic disturbance, as we've seen in the previous pictures, there are severe requirement for the open trench. You need to block entire roads. Rerouting will be required, and there'll be a lot of traffic jams. And for the open trench, for the trenchless, sorry, it is very minimal. Only slight diversion will be required. Another important aspect is the installation depth. In countries where the sewage network is the old sewage network is already condensed, and it will be needed in order to install for new networks. You need to go deeper, and that will not be possible with open trench installation. Usually the open trench is limited up to around 6 meters, plus or minus, depending on the location, if it's open, if it's open areas or not. But for the trenchless, you can go very deep, even up to 30 meters. We have pipes already installed in Singapore at around 30-meter depths. So this is a picture which will explain the points which I've highlighted earlier in the previous slide. So you have here the pipe is installed, and on the right side is the open trench method. On the left side is the trenchless. So we can see clearly above the pipe, no disturbance to the soil whatsoever. Whereas on the open trench, you require special bedding material. This will be imported soil. And then you have another backfill. It can be either the native soil or imported soil. And then, of course, you need to do the road repairs on top. So I will display a video now, so you can have an idea of the process.
The following animation shows the installation of new sewer pipes EN 600 in an urban crossroad with dense traffic. The whole construction site can be located in a way that only one lane is blocked. The first stage, the area around the starting shaft is cordoned off to divert the traffic. Due to the compact design of the machine and the small diameter of the starting shaft, there will only be minor disruption to the traffic flow. In this case, the starting shaft consists of a round shaft of reinforced concrete with an inner diameter of 3.2 meters. The compact jacking frame is then placed into the starting shaft, and the slurry discharge pump is mounted on a platform adjacent to the jacking frame. The operating container with the control panel and the hydraulic power pack is located on the top rear side of the shaft. A pipe stalk is then established and maintained in front of the shaft to feed the shaft crane. The slurry feed pump and the slurry discharge pump are connected between the shaft and the control container, and then connected through the separation plant to form a closed slurry circuit. Large stones are crushed by the discs of the cutting wheel. Sometimes fragments are being driven out to the surrounding soil. The product pipes are lowered into the shaft one after the other and connected with snap connectors. The jacking frame works in 3 stages. After approximately 1/3 of the maximum piston stroke, the jacking arms return and the main thrust ring of the jack can advance further. After jacking the product pipe, the connecting hoses, which connect the TBM to the container, are disconnected. The jacking frame is returned to its original position, and the next product pipe is connected. This procedure is duplicated again and again until the whole drive length is completed, reaching the reception pit. Crossing pipes in buildings are no problem with this technique, as they can be easily overpassed or undercrossed. Thus, the machine arrives in the reception shaft exactly at the planned coordinates. In our example, the total of 150 meters of new pipes could be realized with only a minimum of disturbance in a difficult infrastructure. The conventional open laying of pipes would have caused major disturbance and annoyance for traffic and the residents.
Okay, so in brief, and this is where what I mentioned is the insert the lowering shaft and the reception shaft. And we can see clearly during the jacking process, there is no disturbance at all to the existing utilities, the cables, the old sewer lines. It is also possible to go deeper below the metro lines, depending on the infrastructure and the current setup in the country. So all of that is also possible, depending, of course, on the pipe strength. So what are the main pipe selection criteria for any project? This is the most important question when selecting pipes for sewers. Of course, the first one I would say is the corrosion resistance, because it has a lot of implications. We know that the sewers, the sulfuric acid in the sewage is very, let's say it's not a joke, it's very corrosive and can really affect the pipelines. So, and based on that, it will affect the lifetime of the pipe. So the first thing is the corrosion resistance. Can the pipe material resist the corrosion or not? Then we have the strength. How strong are the pipes? Because that will depend on the maximum allowed jacking force. That will depend also on how deep the pipes can be installed. So it will affect the plan of the installation process and how far one can go with the design of the pipes. And we have also the joint design and leak tight proof. Of course, after all the investment and installation process, you'd want to have very secure pipes which do not leak. Service life, how long will these pipes live? How long are they going to work for? They're going to give us the value. So investing in pipes which would require change in a short period of time, let's say 10 years or 20 years, versus pipes which would take much longer time, 50 years or even 100 years. Ease of installation. How easy is it to install the pipes? Do you require special materials or special process to install compared to other materials, other pipe materials available in the market? The flow. This is another important aspect in design, which will affect the size of the pipe, the required, if there will be any pumps to be used, the slope, which will be implemented in the design. So all of these will be affected in terms of the flow. The maintenance. Do the pipes require a lot of maintenance in order to give us their designed life, service life, or not? We know that there are many pipes, many instances where pipes have to be maintained regularly in order to give the designed service life, and those maintenance costs are very expensive. Eventually, some may reach to the actual cost of installing the pipes, new pipes. And the conductivity, whether it is thermal or electrical. There are some special applications where you need to use the pipelines, not for sewage, but for carrying electrical cables. And you would want that there are no kind of interference in the pipes, like if there's any steel in the pipe body. So you may need products which are non-conductive. And for thermal, if there is a lot of change in the temperature, of course, when we go underground, it's not much of an impact. But if we're talking about shallow pipes, or if there's going to be some exposure for the pipes at any given point, are the pipes going to be affected by the changes in temperature? And then the cost. So some of the clients would look at the cost as comparing pipe A and pipe B directly. And I always say it is very important to consider all of these points above, which because they really contribute to the overall cost of the entire project. It is not just the pipe material cost, it is the entire system has to be looked at all together. And that really makes a difference at the end of the project. So what are the types of pipes which are available in the market? You have the oldest pipes available, which have been used, and they've been dated back to the Roman times, and that is the vitrified or the clay pipes. Then you have the reinforced concrete pipes. You also have the GRP jacking pipes, and these there are two main manufacturing processes. The initial one, which started, was the centrifugal casting, and followed recently. There's a spread in the filament wound jacking pipes, GRP jacking pipes, and you have polymer concrete pipes. There are two main methods of the casting of these pipes. You have one is the vertical cast. The other one is also the centrifugal cast. And then you have the composite polymer concrete pipes, our MI pipes. So what is unique about our pipes? The unique composite pipe for the Frenchless spoon. What is unique about MI pipes? What is special? Our pipes are a combination. It's a composite, which gives you the best of the two worlds, the best of polymer concrete and GRP. So it uses the strength and corrosion resistance of polymer concrete, as well as the enhanced properties of GRP. So first, you have the long life in terms of the advantages. You have the long life. They've been designed for 100 years. So the international standards require that the pipe samples are tested in, are placed in solutions of pH 1, hydrochloric acid, and pH 10 for sodium hydroxide. And these samples would have to be kept under load for a period of 10,000 hours. That's around 14 months. And that is only the testing period. So you'll have, of course, a setup period before that. So after this period, the results are extrapolated to 50 years as per the standards. However, we have extrapolated the results further to 100 years, and we've proven that our pipes can still withstand the acid and alkali test conditions. So this is a picture which shows the previous setup, which was under the ASTM and the old DIN standard. And here you can see the load is applied, and at the same time, the acid and the alkali solutions are only inside the pipes. However, as per the new standard, the entire pipe will have to be, I mean, the internal and external of the pipe will have to be submerged in the acid, in the solution, whether it is acid or the alkali. And of course, the load will be applied on top. So it is even more rigorous. So our pipes are totally corrosion resistant. With the unique design of the MI pipes, with its internal GRP liners, they are totally corrosion resistant to all chemicals found in water, sewage, and the ground. So polymer concrete alone is corrosion resistant thanks to the resin, the polyester resins which are used to make them. And add to that an extra layer of protection given by the fiberglass. So we have the smooth internal and external surface and the better flow. So the GRP liner provides a very smooth internal surface, which has a minimum Hazer-Williams value of 150 and a Manning coefficient of 0.009. Thus, the amount of sludge which would normally accumulate on pipe surfaces is much less when compared to other types of pipes. The Manning coefficient of the vitrified clay pipes and the RC pipes, the reinforced concrete pipes, is greater than 0.013, and this will deteriorate with time. For the low friction loss, the smooth and glossy exterior surface of our pipes, because we also have an external GRP liner, which is very smooth and glossy, this reduces the friction and thus reduces the jacking loads required during the installation process. This surface is also totally impervious and does not absorb moisture, and thus the pipe weight remains the same from beginning to end of the installation. You have high strength. The polymer concrete is 3 times stronger than conventional concrete. It has a compressive strength of more than 19 newtons per square millimeter. It is non-conductive, as I mentioned earlier, so with special applications like transferring electrical cables, polymer concrete pipes with GRP sleeves may be used since they do not conduct electricity. And then low thermal conductivity, also the polymer concrete can withstand great changes in temperature without any impact on their strength and properties. Our product is made in Malaysia. This allows, if we're talking about the Asian countries, Australia and New Zealand, so the shipping costs and the faster delivery is possible from here. And there are, of course, a lot of there are free trade agreements with multiple countries and also for the ASEAN countries. So you have reduced import duties. Maintenance free, being completely non-corrosive. There is no maintenance required. With its smooth, shiny interior surface, simple water jetting returns the pipe to its original condition. This is another important aspect in our product range, where we have the fittings we supply a full range of fittings, including bends, elbows, T, Y for the backdrops and tumbling base. And this is a picture to give you an idea. So we can provide 45-degree, 90-degree elbows, T and Y. And these can also be custom made depending on the project requirements. And this ensures that you have a uniform system from A to Z, from the one manhole to the second to the other manhole. You have a complete system without any difference in materials. And then you might have some compatibility or joining problems and so on. So we provide a full range of products. So for the customization, our products can be custom made according to client, project, and site requirements. So by saying that, you can have, for example, you might have a customer who has a specific pipe jacking machine requirement. So they may require, because of the jacking head, they may require a certain size. So we can custom make our pipe to match that requirement. We are very flexible in changing the OD of the pipe as required for any specific project. Then you have the jacking force requirements for certain projects, certain depths, and maybe for a long drive, it may be required to have a high jacking force, and that will also result in a higher thickness, and thus we can also cater to that requirement. Then you have special, as I mentioned, special or even custom-made fittings, which would match the exact site conditions. So we have our standard range with standard dimensions, and also we usually get a lot of common requirements or requests from customers. As you are aware that there are a lot of surprises which take place during the installation process and things which are unforeseen. So to minimize that impact, we can provide custom-made fittings such that they will be easily installed at site. And then special pipe applications. It is required, it is known that in industrial areas, it is common that some of the factories do not abide by the local regulations, or maybe the local regulations are not fully enforced or set, depending on the country and the level of the restrictions which they apply. So in these industrial areas, there may be a lot of dumping for chemicals inside the sewage lines. So in order to, and these chemicals might be even more corrosive. So a regular pipeline may not survive, and even a corrosive resistant pipeline might have some problems. As such, we can modify our pipes. Our internal liner can be modified with a special type of resin, the vinyl ester resin, which is highly chemical resistant. And usually this resin is more expensive than the other standard polyester resins. And as such, the temperature will, the price will increase slightly only, which is because it's only on the liner, not the entire pipe body. So there will be minimal impact on the price increase. But at the same time, you'll have a product which is even more chemical resistant and which can sustain dumping of chemicals and even high temperature liquids from industrial areas. We come to the joint details now. we have a special, it's of course for the jacking pipes, you require a spigot joint. We have a special design for our joint whereby the rubber gasket would sit in a groove. This ensures that there is no, it is fitted perfectly inside this groove, and during the installation process, when it is fit inside the sleeve, there is no chance of it flipping. There are many other pipes available in the market where there's merely a 2 mm step which the rubber would sit on, and that's the main impact of that, or the main hindrance, drawback of it, is that depending on the installer, there is a very big probability that the rubber would flip, and it will go unnoticed. And it will only be realized once the pipes are tested and they find that they're leaking. We provide a different range of sleeve options. Since you require a sleeve to join the pipes, it's a flexible joint. So we can either provide it in stainless steel, mild steel, or even in GRP sleeves. Now, one would ask, why should we use stainless steel, or why should we use the GRP? It's, to be honest, it's the requirements of the client and what they prefer. In some parts of the world, like you talk about the Kuwait, the Gulf countries, they prefer to go for the GRP sleeves. They're very reliable, they're strong, they're corrosion resistant, even better performance in terms of corrosion resistance than stainless steel. And even can be installed in salty and areas which are near the sea. So the performance is better. Other clients would prefer, they prefer to go for stainless steel sleeves. For example, Singapore, they prefer to go for the stainless steel sleeves. So it's just a preference of the client. For us, we provide the full range for both desires, whether it is the stainless steel or the mild steel or even the GRP sleeves. Quality control is a must, of course, in any process, in any product. We carry out complete quality control on the raw materials during production and after production. And this is a picture showing the leak test. And in this process, we fill the pipes, we apply the load on top of it here, and we also apply deflection, and we pressurize the pipes depending on the requirement. Now, the standard requirement is 1 bar, but we have tested our pipes thanks to our joint design. Our pipes can go to a much higher pressure. We've reached pressures, internal pressures of around 5, 6 bars, and even for some sizes, even 10 bars. If we're talking about deflection, including the deflection, 5 bars. And for the external pressure, we have reached pressures of about 4 to 5 bars. And this is another leak test conducted on our open cut joint, which is sometimes you have to conduct open cut installation. And this is usually the joint which can be used for the open cut, where you have the socket and spigot joint. And you can see very clearly how glossy the surface is of our pipes. And here is the crushing strength test. The BS standard requires a proof load test. Depending on there's a certain calculation which is done, which takes into account the diameter of the pipe. And based on that, the load must be applied. Previously, the DIN standard, the old DIN standard, required a complete crushing of the pipe. Now this is not required. We only do that as a type test when to confirm the ultimate strength of the pipe. So because that will be required in the calculations to ensure that the pipes can withstand the loads underground. So we come to an interesting, I hope, an interesting part where we compare different types of pipe materials. So here we have the Manning's coefficient, the Hazen-Williams value for 4 types of pipes. You have the vitrified clay pipes and the reinforced clay pipes. And you can see that the Manning's coefficient deteriorates with time. It usually starts around 0.013 and can go up to 0.016 or even higher. PVC pipes are having a better Manning's coefficient. And then for the polymer concrete pipes, it's 0.009. For the comparison in terms of the internal external diameters and the weight, you have higher thickness for the same internal diameter. You have higher thickness for the clay pipes and the RC pipes. And of course, that will also impact the higher thickness will also impact the weight of the pipe. So what would the weight impact? It will impact the handling at site during the installation process. All that plays a role. So if you have a lighter weight pipe, it will be easier to handle and transport and so on. And of course, the cost will be less. The jacking strength, we can see these are the information available for our standard duty pipes. We have two ranges of pipes, standard duty and heavy duty. So I'm trying to compare with the minimum available. And we can see that for the same diameters, like for example, we have a 260 internal, here it's 250. The external diameter is much less, and the jacking strength is almost the same. And we can see for the remaining sizes, the jacking strength increases and goes higher. Now, the concrete pipes have higher jacking strength compared to the standard pipes. However, the thickness is much greater. So what does that what is the impact of that? That means that the installing contractor will have to use a bigger and more expensive machine. There will be a lot of more soil to be removed during the installation process, and that will add the costs during the installation. So why are strength and corrosion resistance important when we talk about pipelines? So this is an example of a pipeline, a non-lined RC pipe. And in this example, this is for a diameter of 900 mm. And the condition of there was an inspection done to this line 5 years prior to this picture. And after the next inspection, they find the pipeline with this condition, which is showing that it is completely corroded on the top. And the steel reinforcement is already visible, and the cement has already been corroded. Another picture shows the condition of the non-lined RC pipes. That is why in many countries, they require that if reinforced concrete pipes are going to be used for sewers, they must have HDPE lining. For the vitrified clay pipes, a common problem for them is the ability to break and shatter during handling and also during the installation. And these are some pictures which show what happens to these pipes. These pipes were broke during the installation process. Okay, another problem is the breakage after installation. These were taken from, they were installed in the US. And a subtle problem, which is common in clay pipes, is the hairline crack. If you notice the picture on the right, you'll find this hairline crack. And this is quite common and disturbing for many clients. And it is unavoidable, as far as I know. And here are some pictures of our pipes being installed into the manhole, into the lowering shaft for installation. And this is where you can see the jacking machine. The workers are preparing the pipe in position so that they can start the jacking process. And here, as you can see, what we've seen in the video, the jack is pushing the pipe inside. Here we can see the joint between the previous pipe and the next pipe, again on this side. I will show you a video. In Singapore, they carry out two types of CCTV recording. One is done in the beginning, just after the pipes have been installed. And the second one is done after 2 years of service. This is a CCTV recording of one of our pipelines, which were installed at 260 mm diameter. So you can see the condition of the pipes after the 2 years of service. So the pipes look almost like new. Only some small discoloring over here, changing color for where the sewer was, but the rest is all the same, as if it's new. What we can see over here is the GRP liner, which is complete. It is completely intact with the. It forms as one unit with the polymer concrete. A common question would come: what happens? Does the GRP liner delaminate or come off from the polymer concrete? We say no. If you want to remove it, you'll have to rip it off, because the materials, the resins used, the materials used for the liner and for the polymer concrete are the same, polyester resins, and so they form a very homogeneous mix. So literally, they become one unit, one part. These pictures show the internal surface. You can see how glossy these the inside of the pipes are. And here we have some pipes ready for shipping. And I've come to the end of this presentation. So we can start the Q&A session. For anyone who has questions, please feel free.
Thank you so much, Mr. Walid. It was really an extremely insightful session for all of us. And I believe everyone is having their questions ready. And I can see a couple of questions on the chat box. So I'll read it out loud for you so that you can answer them. The first question was from Mr. Kaushalendra Shukla. He's asking, what are the key jointing methods for these pipes, and are these pipes repairable in case of damages?
Okay. The key joining, basically you have the flexible joint where the two pipes are joined by the sleeve. If you recall, I've clearly showed the sleeves which are used, and that is when the pipes are inserted and they're kept together with the sleeve, and the rubber gasket will provide the leak tight effect. For the repair of the pipes, it will depend on the type of damage. If we're talking about minor damage like some scratches or some minor, let's say if some drilling or something happened to it, unintentional or not unintentional, which is not as per the design requirements, then it is possible to do some repairs. For larger diameters, it's much easier. Someone can actually go inside and do the repair. For smaller diameters, it can be done using robotic repair, and that is basically you brush off the surface and then you coat it off with special resin.
Thank you so much, Walid. I hope, Kaushalendra, you have your answer. Next is a question from Mr. Puranik. He's asking, what is code of concrete for pipes? Are you manufacturing pipes as per coding norms specified in certain countries?
We are following the BSCN standard, which is for the polymer concrete pipes, not for the reinforced concrete pipes. It will depend. If you have specific norms required for certain countries, then you can share them with us, and we can advise you and tell you which one is we can meet and so on.
Right. Thank you so much again, Walid. So the next question is from Mr. Janak Kumar Patel. He's asking, can we manufacture it on small diameter like 2 and 3 inches? So I'll add up to this question like, what could be the maximum or minimum length of those pipes? What could be the minimum or maximum diameter or like the radius of the pipes? So if you can answer, and both in terms of like in general, what is available in the market and what Meepa pipes provide.
Yes. Normally the lowest diameter available in the market is around 260 mm. We can manufacture starting from 200 mm. And at the moment we go up to around 1,000, 1,200 mm. It is possible to manufacture much larger pipes. I've previously manufactured in Kuwait pipes up to 2,400 diameter. And recently, a couple of years ago, there was a redesign in the sewer standard, and where they started to use pipes up to 3.6 meters in diameter. So it is possible to cast much larger diameters. So the most common was up to 2.4 meters, and I believe recently it's been available for larger diameters, up to 3.6. For the length, usually because it's a vertical cast, the lengths are limited. It's between 2 to 3 meters as standard. For us, we can give the 2 meter standard and also lower 1 meter. And custom-made lengths can also be done depending on customer requirements.
Great, awesome. So there's a question from Sophie Manda. The question is regarding the manufacturing of PC pipes using vertical casting. Is it required pressing?
No, we use the vibration to provide the compression. So all the pipes during the casting process, you need to carry out vibration, and then that will provide the necessary compaction and remove any air bubbles.
Right. The next question is from Mr. Febin. He's asking, is it required to change the rubber seal used at the joint over a period?
No, it's not. The pipe's already installed underground, so there's no way that you can take out the rubber. Right.
Next one is from Mr. Kalpesh. He's asking, any application of such pipes in water park industry?
No, I think for the water parks, you would tend to use more into the GRP pipes because they're lighter in weight. These will be much heavier comparing to GRP pipes. I'm assuming that you're talking about above ground installations.
I believe the same is the question. The next question is from Mr. Suresh. He's asking what type of rubber material used in joining areas like EPDM nitride?
Yes, EPDM is usually the material of choice.
Great. The next one is from Mr. Bhavarlal. He is asking what is Ingress protection rating at joining area or at rubber sealing?
I'm not sure if I understand the question properly.
Okay. So I'll ask Mr. Bhavar if you can unmute yourself or to just clarify the question. Meanwhile, I'll read the next one. I believe
the cost efficiency between MI pipes and PVC pipes. Now, PVC pipes would have a limitation. If we're talking about jacking pipe installations, they would have a limitation on size. I'm not aware of PVC pipes if they're used in India, but I am aware of those used in Indonesia, and our pipes are competitive, but they have a limit in the diameter. I think the maximum which they're reaching is about 300 mm. So for larger diameters, it's not possible to go for the PVC pipes in terms of jacking pipes.
Okay, I guess Mr. Arnath has his answer. So there's another question from Sophie. What types of aggregates that are usually employed to produce PC pipes? From the image that Mr. Walid shared, I guess sands and gravels.
Correct. Usually it's sand and gravel, depending on the location where the factory is. Some factories may use the pebbles, the stones from the rivers. So it's basically you try to accommodate from what is available near you. So you need a combination of stones and sand. You cannot just depend on one alone.
Great, thank you. So are there any further questions that you have for Walid? Please keep them coming. I guess Mr. Bhavarlal is unmuted. Yes, like if you can just clarify your question.
Yes, sir. Just I want to understand that sealing zone. What is ingress protection rating? Suppose rubber seals are putting there. So rubbers have a permeability value, some like EPDM or whatever elastomer using. So what ingress protection rating? Any test is conducted, or how is the leak proof? That any test methods is adopted for?
Yeah, there are test methods, tests required as per the standard, and I don't recall the exact standard number at the moment. But we have to follow these standards and make sure that the pipes, the rubber meet these requirements.
Okay.
I believe, Mr. Baba, your question has been answered. Thank you.
Yeah, I got it. Yeah, thank you.
Thank you. So we have another question from Harnath sir. He's asking, any periodic maintenance is required for Meepa pipes?
No, there is no maintenance required. Once the pipes are installed, you can relax and just they will do the job.
Great. There's a question from Mr. S.K. Lim. He's asking, what's function of aggregate? Is it filler?
You have, yes, basically it's a combination of the aggregate and sand will be the filler. The aggregate will be more into the strength of providing the strength of the pipe, and the sand will be filling more into the, so you don't have a porous mix. You need to have a perfectly sealed, a perfect homogeneous mix to make sure that there is no water penetrating through.
Right. The next one is from Herman, bulk density of the gravel. What is the bulk density of gravel?
Not sure. You can use different sizes. If you're talking about the size of the gravel, then that different sizes can be used depending on the design of the mix design and as well as the machine capabilities.
There is another question from Sophie. In terms of property, what is PC pipe's general behavior? Is it brittle as cement concrete pipe or ductile as metal pipe?
No, it is not it is more like concrete pipe, reinforced concrete pipe, but a bit better.
Right.
But definitely not like ductile.
Great. So the next question is, what is the best technique for leakages, if any, duration operation, as it's installed more than 30 meters depth? It's a question from Nadi.
Yes. Technique for leakage. Usually, if there are some problems if there is some doubt of any leakage or any problem that may have occurred to the line, the best way is to go for the CCTV inspection. Because these are not conductive, you cannot do any type of, and there's also no pressure, so you cannot do any type of tracing from the surface to see, and we talk also about 30-meter depth, so it's quite hard to detect. So you need to go deep and do the CCTV recording to check.
Right. I like this question from Mr. Harnath. His question is, do the Meepa pipes has any plans to use recycled materials?
At the moment, to be honest, no. But these are, I have considered that in the past, and basically recycled in the sense of the resins, where PET can be used to manufacture the resins. So that is a form of recycling the materials. Other than that, it is not, it is possible to use, how should I say, the impact recycling will have the materials you're talking about. You have the stones, the filler, the stones and the sand, and you have the resins. So the resins is where you can have recycled in terms of PET, but for the stones you need to have clean stones. You cannot use, for example, stones which have been, let's say, from the road, from the asphalt. That would impact the curing process because it would not be pure and clean material. So the use of recycled materials is quite limited. It's not open-ended.
Great. So Harnath, Mr. Harnath has said, yes, I'm interested about the recycled resins if they can be used.
Yes, it is possible. Of course, you need to maintain the mechanical properties because they will impact, of course, the overall strength of the pipe.
Great. Okay. Any further questions to anyone? If anyone wants to ask any questions, please feel free to ask. Okay, another question from Sophie. Where is the location of your Meepa pipes manufacturing process? I guess he has shared it's in Malaysia. If possible, maybe visit your manufacturing site. That I think you can answer.
Of course, most welcome. Of course, at the moment, due to the corona, the COVID-19, the moment Malaysia the borders are closed. However, after this situation improves, then of course you're most welcome to come and visit. And we're also, to be honest, we're also looking for possible ventures into India. So if there are any interested parties where we can work together, please do let us know.
Amazing, amazing. I believe there'll be people who might be interested.
That's
So
great.
any more questions do we have? If not, I believe let's conclude the session. So thank you, Mr. Walid, for this wonderful, insightful session. I request our beloved Mr. Harnath Babu to give the vote of thanks and conclude the whole web symposium. Sir, if you can unmute yourself. Thank you so much, sir. Thank you.
Thank you, Prashant. Thanks for giving me the opportunity to give the vote of thanks. First of all, let me give a big thanks to Mr. Walid about giving this most insightful and knowledgeable session, and the patience how he has shown during the answering the questions about the design point of view and maintenance point of view, and also the future innovations what are all available. And he covered almost across the globe, like everything. There is no point of missing anything out of it. And thank you so much for your extensive session. And we want you to be involved in all other future CECA Asia presentations and all the insights. So we are looking into the making India as a composite hub by 2030 is the goal for our CECA Asia. And your contribution and your what you call the innovative ideas and manufacturing collaboration with Indian companies and organizations, it is most welcome. And also I request all the entrepreneurs who are all there in this webinar, make use of this particular idea and the design and how the MI industries are using for the replacement of the stainless steel or clay pipes or PVC pipes in terms of the tensile strengths and the leak-proof methods, and how the joining facilities and the how they can impact the stakeholders like the common public by avoiding the traffic jams and much more. It is rather than the cost efficiency, there is a easiness, and the most important is ease of life. So thank you so much, Walid, and thank you, Prashant, for your this thing. And once again, I really thanks to Mr. Dr. R.K. Singh sir for giving this opportunity to connecting the people like across the globe, and making this particular forum most insightful and helpful manner, bringing into this particular forum, and restlessly he is striving hard to get the connect the people across the globe and making it happen. Thank you so much once again. Thank you, Prashant.
Thank you so much, sir. It's always pleasure to have the vote of thanks from you. Thank you so much again, Harnath sir. Thank you, Mr. Walid, again for this wonderful, insightful session. I'm very proud enough that we had this like one of a unique products that is like a very old, which we generally think that it's like something a new product. So thank you for breaking the myth, and thank you all the participants for joining us. This session you can find this session live on YouTube, which is like currently live. You can find it later on our YouTube channel on CECA Asia. So this is something part of, again, like the movement that we have taken care of, like to make India hub of composites by the year 2030. So these sessions go on YouTube channel so that people keep looking for some composite content and they get excited and intimidated about this whole movement. So please let's take this as a common goal, and let's keep striving with more and more of such sessions. We're very much happy to take feedback, suggestions on different topics that you would wish CECA Asia to have such symposiums. So please feel free to mail us, call us, or post any messages on our LinkedIn page. So thank you so much. Thank you once again, everyone. So I'll just close this session. Thank you so much, Mr. Walid again. Thank you, Harnath sir, for the vote of thanks. Thank you, participants. Bye.
Thank you. Thank you.
Have a good evening.